This part almost stopped my turbine project. The diffuser looks simple, but machining it on a hobby CNC turned out to be way more complex than I expected. Multiple setups, 4-axis machining, and a lot of trial and error. In this video, I'll show you what worked and what didn't. Hi guys, I'm Alfonso, and welcome back to Alfmart CNC Garage. The diffuser has a very complex geometry, so machining it requires careful planning. Each side, top, bottom, and lateral faces must be machined in different setups, using dedicated fixtures. Getting the sequence right is critical to achieve accuracy and avoid collisions. I start by preparing the raw stock on the lathe. The material is aluminum 6063. The operations include turning to near final dimensions, leaving a 2 mm machining allowance, finishing the inner bore to 25 mm and facing to a final width of 20 mm. I start with the internal side, the one facing the engine, as it's the simplest reference. The machining strategy is adaptive clearing for roughing, efficiently removing large amounts of material while maintaining constant tool load. Contour passes to define the external profile, finishing at nominal dimension. A 2D pocket to finish the flat internal surface. Finally, a 3D contour, using a 12 mm ball end mill to remove the remaining material. For the external side, I use a similar approach, starting with adaptive clearing and 2D contour, leaving 0.3 mm stock for finishing. Then, I apply multiple 2D pocket operations to achieve the final edge definition. This is one of the most critical steps to get clean, sharp edges. This is where I realized my initial strategy wasn't going to work. To finish the inclined surfaces between edges, I use a radial strategy, leaving a 0.2 mm safety margin to protect the edges. This operation is repeated using a circular pattern with 15 instances. For this setup, I designed a custom support fixture to mount the diffuser on my fourth axis. First, I machined the main edges using a 2D contour, roughing in 3 depth passes, leaving 0.2 mm stock. A final finishing pass at nominal dimension. Then I indexed the part in 4 positions to drill and tap M3 threads. Finally, I machined the smaller edges using the same contour strategy. Here, I use nested patterns to machine all the small edges while skipping the main ones. Working on this part and exploring different Fusion 360 strategies has been a great learning experience. Even as a beginner in CAM, I was able to produce a complex and functional component for my turbine. I hope you found this useful. If you did, don't forget to like and subscribe so you don't miss Part 8 of the RC turbine build. Thanks for watching, and see you in the next one.